So today we're going to talk about the unit circle, what it is, how we use it, and why we use it. We've been talking about trig functions to find in a right triangle, and we had certain definitions for sine, cosine, tangent. But now we're going to have new definitions for those trig functions because now we're taking it outside of right triangle. So a unit circle is simply this, a circle whose center is at the origin and has a radius of 1. So I actually know 4 coordinates based on this unit circle. I know the coordinates of this point are 1, 0. This point is 0, 1. This point is negative 1, 0. And this point is 0, negative 1. And now that is going to help us as we talk about angles and trig functions associated with those angles. And so if we talk about the sine of an angle, we're talking about an angle in standard position. An angle in standard position is when the initial side is on the x-axis and the vertex of the angle is at the origin. The side of an angle in standard position is the y-coordinate of the point where the terminal side of the angle intersects the unit circle. So let me demonstrate what I mean by that. If this is a point on my circle, I'll call this point xy. I know because this is a circle of radius 1 that the length of this line segment is 1 unit. I also know that this height, because this point is represented by the coordinates xy, this height is y units, and I know that this distance is x units. And what that does is that creates a right triangle. If I were to fill in this angle here, and I said that this angle was theta, it's really hard to see, but that's a theta, and I use my definitions for right triangle trigonometry, and I say, okay, well, sine of an angle is always opposite over hypotenuse. So in this case, the sine of my angle is going to be the opposite side of this triangle, which is designated by y, and the hypotenuse, which is 1. So I can say then that y is equal to the sine of theta. Okay, so anytime you have a unit circle, the y-coordinate of a point on the unit circle can be found simply by taking the sine of the angle formed by the x-axis and the line segment that goes from the origin to the point on the unit circle. Same is true when I'm talking about the cosine. If this point right here is my point xy, again, this line segment here is 1. This distance right here is y. This distance right here is x. If theta is my angle, so theta is my angle formed between that initial side of my angle, which is the x-axis, and the line segment that goes to that point. Remember, cosine of your angle is adjacent over hypotenuse. So the cosine of the angle is going to be x over 1, or we can say that x is equal to the cosine of theta. Now, if we go to the last one, and this actually should say tangent, not cosine. If we go to our last picture here, and here's our point x, y. Here's our triangle. Remember that this distance is x, this distance is y, this is 1, and my theta is here. Oops, that's a theta there. I know that's kind of hard to see. When we talk about tangent, remember that tangent of an angle is represented by opposite over adjacent. In this case, the opposite side is y, and the adjacent side is x. And so we can say that y over x is equal to the tangent of theta. So these are new definitions that we can use so that we can find the measure of any angle within a unit circle. So let me show you how we're going to do that. In this example, I have this point. The coordinates of this point are 4/5, 3/5. Remember, we've got an x-coordinate and a y-coordinate. Theta, which is not drawn in the picture but should be in there, so you can draw that in on your picture. Theta is that angle there. So they're asking us to find our 6 trig functions. We know that because this circle, this is a point on the circle that, and this is the angle theta that I'm looking for, that the rules or the definitions that we just came up with apply. So the sine of theta is the y-coordinate of the point. So my sine of theta would be 3/5. Right? My cosine is the x-coordinate. That would be 4/5. A lot of times people mix up which is which. So a little kind of helpful tip. Remember x, it's alphabetical. X comes before y, cosine comes before sine. So if that helps you remember which is which, cosine is x, sine is y. Okay. Tangent is y over x. So our tangent is going to be 3/5 over 4/5. Right, so I'll do that over here. 3/5 divided by 4/5 is the same as 3/5 times 5/4. So those 5s would cancel out. And so that would give me 3/4 as my answer here. Okay, remember that cosecant is the reciprocal of sine. So if the sine is 3/5, the cosecant is 5/3. The secant flips cosine, so if cosine is 4/5, the secant is 5/4. And cotangent flips tangent, so if the tangent was 3/4, the cotangent is 4/3. Now, the next question here says to find theta to the nearest degree. We can easily do this using our calculator. Just want to make sure that our calculator is in the right form or the right mode. So it says to the nearest degree. So we want to make sure that we are in degrees. So make sure you change that in your calculator before doing this. And again, we know what the sine is. We know what the ratio is. And you can use any one of these. I'm just going to use sine because it's the first one I have here. So if I hit second sine and I do 3 divided by 5 and hit enter, it'll give me that angle in decimal form. So it's to the nearest degree. That's going to be 37 degrees. So we can say approximately 37 degrees. Now, the reason that we do these definitions is to help us to understand the different signs of our trig functions depending on the size of our angle. We've been talking about angles only in right triangles. So of course that limits the size of our angles. That means we're always dealing with acute angles. Once we take it out of a right triangle, and we now think of it in terms of the unit circle, we now have 4 quadrants that we're dealing with. And not only are we dealing with 4 quadrants, but we're dealing with angles that are larger than 90 degrees. So that means that we're going to have signs, meaning positive or negative, associated with our trig functions. It just depends on where you are as to what your trig function is, the sign of your trig function. So if I'm in the first quadrant, I know that both x and y are positive, which tells me that the sine, because sine is represented by the y-coordinate, so sine is positive. Cosine, which is represented by the x-coordinate, is also positive, and because they're both positive and tangent is y over x, I know that the tangent is positive. I'm not going to talk in detail about the reciprocal trig functions, but just keep in mind they're going to maintain the same sign as their reciprocals. So sine and cosecant are reciprocals, which means cosecant will have the same sign that sine has. Secant will have the same sign that cosine does. cotangent will have the same sign that tangent does. So in the first quadrant, all of our trig functions are positive. So I'm just going to use the letter A here to signify that they're all positive. Okay, when I get into the second quadrant, any point on my unit circle that is in the second quadrant, the x-coordinate is negative and the y-coordinate is positive. So if the x-coordinate is negative, that means that the cosine is negative, because the cosine, remember, is represented by the x-coordinate. If cosine is negative, that means that the tangent, because tangent is y over x, is also going to be negative, right? So tangent is negative. Kind of trying to squeeze that in there. Sine is represented by the y-coordinate, so sine there is positive. So the only thing that's positive in that second quadrant is sine. Okay, let's skip down to the third quadrant here. Remember, in the third quadrant, I've got negative x and negative y. So both x and y are negative. That tells me that cosine is negative, that sine is going to be negative. But tangent, remember, tangent is y over x. So since they're both negative, tangent is going to be positive. So the only thing that's positive in that third quadrant is the tangent. In the fourth quadrant, any point in the fourth quadrant is going to have a positive x-coordinate and a negative y-coordinate. This means that cosine would be positive, sine would be negative, and because tangent is y over x, tangent would also be negative. So in the fourth quadrant, only the cosine is positive. Now, this little visual hopefully will be helpful to you, and this is all I need you to remember with this visual, and you can put this on the top of any homework assignment, any test paper, any quiz, or whatever, but this is what you're looking as a way to remember. ASTC. So you can kind of use that acronym. You can name it whatever you want. All Snickers taste chocolatey, or the one they always use is all students take calculus, but that's not always necessarily true. Whatever you want to use to remember it. And all this is telling you is what's positive in which quadrant. So in the first quadrant, all trig functions are positive. In the second, only sine is positive. In the third, only tangent is positive. In the fourth, only cosine is positive. And so that's going to help us to answer questions like this. So for example, determine the quadrant in which theta lies. Okay, well, I have two things here, so I need both of these to determine the quadrant. If sine is positive, that means I'm in either 1 or 2, based on my little chart over here. And if cosine is negative, remember this chart only shows where things are positive. Cosine is positive in 1 and 4, but it's negative in 2 and 3. So what's common to both of these is 2, so that tells me I'm in quadrant 2. Okay, in the next one, tangent is positive. Well, tangent is positive in 1 and 3. Secant is negative. Remember, secant flips cosine. So wherever cosine is negative, secant is negative. Cosine is negative in 2 and 3. So my answer here is quadrant 3. And the last one here, cosecant is negative. Remember, cosecant does the same thing that sine does. So cosecant is negative wherever sine is negative. That would be 3 and 4. Cotangent does the same thing as tangent. So tangent is negative in 2 and 4. And so what I have in common here is quadrant 4. And that's how you're going to answer those problems. Okay, so this is really right here. This is the thing that's going to help you with any problem and moving forward with all the problems that we do. So make sure you remember that. Thanks, everyone.